Hi, my name is Julie, and I'll be guiding you through this training. Here are the objectives for this course. What is matter? Everything around you is matter. This is TWPF. Everything in this picture is matter. Remember, anything that has mass and takes up space is matter. Matter comes in three physical states: solid, liquid, and gas. Matter exists in different physical forms under different conditions. Water, for example, exists as ice, a solid, water, a liquid, and steam, a gas. In this glass, we have some cubes of ice, which as we all know is water in its solid form. We add to the glass water in its liquid form. Outside the glass is water vapor, or water in its gaseous form. Two terms associated with matter are volume and shape. We all know what shape is, so what is volume? Volume is the amount of space an object takes up. Without me or the clothes, the closet is an empty space, but once the clothes and I are placed within, we take up the once available space in the closet, meaning we have volume. Solids have a definite shape and a definite volume. Liquids have a definite volume, but no definite shape. Liquids take the shape of their container. Gases have no definite shape and no definite volume. Gases take the shape and volume of their container. Phase change occurs when materials change temperature. As energy, usually in the form of heat, is applied to the material, the atoms and molecules start vibrating and moving faster. In solids, atoms and/or molecules are packed together tight. If you add energy, they move faster and spread out and become a liquid. If you add even more energy, they move even faster and become a gas or vapor. Think of a football team. When they're in the huddle, the players are barely moving and packed together like a solid. When they break the huddle, players are moving faster and are more spread out, like a liquid. Finally, when the play starts, they're moving at their fastest speed, like a gas. Melting is changing from solid to liquid. The temperature at which this occurs is called the melting point. Freezing is changing from liquid to solid. The temperature at which this occurs is called the freezing point. Freezing point and melting point of a material are the same temperature. Example, if you lower the temperature of water, it will freeze, become ice, at 0 degrees Celsius. If you raise the temperature of ice, it will begin melting at 0 degrees Celsius. Boiling is changing from a liquid to a gas at the boiling point. But you don't have to raise the temperature of a liquid to the boiling point to get it to change to a gas. Puddles of rainwater disappear when the sun comes out. But the temperature doesn't reach the boiling point. Evaporation is the change from a liquid to a gas below the boiling point. Condensation is changing from a gas to a liquid. Water droplets are formed when water vapor in the air cools and changes into water when it meets the cold surface of the glass. Dew drops are droplets of water that have condensed on a cool surface overnight from water vapor in the air. Sublimation is the change from the solid phase directly to gas phase without becoming a liquid. This happens very rarely. One example is frozen carbon dioxide or dry ice. Another example is a solid air freshener. Chemical changes are reactions between substances that form new substances. Here are some examples of chemical changes. Iron combines with oxygen to form a new substance, iron oxide, better known as rust. Wood combines with oxygen, along with heat, to form carbon, better known as ash. Sodium combines with chlorine to form sodium chloride, better known as table salt. These are chemical changes because there was a chemical reaction that resulted in new substances formed with totally different chemical properties than the original substances that reacted. All matter can be classified as either a pure substance or a mixture. Pure substances are homogeneous, meaning they appear uniform in appearance and composition, no matter how small the sample size. Pure substances have the same composition and properties throughout. A sample of a pure substance cannot be separated by physical means, and the composition of a pure substance is definite or fixed. Pure substances are classified as either elements or compounds. An element is matter in its most basic form. An element cannot be separated into other simpler substances. There are currently 118 confirmed elements, 94 of which are naturally occurring. Each element has its own unique chemical symbol. As stated earlier, you cannot separate an element into other simpler substances. But you can separate an element into its smallest form, the atom. An atom is the smallest particle of an element that can exist either alone or in combination with other atoms. Each element is composed of only one type of atom. A compound is two or more elements chemically combined in fixed proportions. Chemically combined means two or more atoms bonded together to form molecules. So, what's a molecule? A molecule is two or more atoms chemically bonded together. A molecule is the smallest piece of a compound that can exist and keep its properties. There are two types of molecules. Molecules of an element which consists of two identical atoms bonded together. There are only 7 total of these. Molecules of an element are also called diatomic molecules. And there are molecules of a compound. They consist of two or more completely different atoms bonded together. There are many of these. Here is a very famous molecule, H2O, also known as water. There will be much more on atoms, molecules, compounds and elements later in this course. We just talked about pure substances, elements and compounds. Now let's discuss mixtures. A mixture is defined as two or more pure substances physically combined in variable proportions. No chemical reaction occurs, no chemical bonds form. A mixture may undergo physical changes, like dissolving, such as sugar into tea. Parts in the mixture can be put together in any ratio. Whether the tea is slightly sweet or syrupy tea, it's still considered tea. Mixtures can be broken down into two categories: homogeneous and heterogeneous. A defining characteristic of heterogeneous mixtures is that the composition differs throughout the sample. In other words, you can identify the different parts. Shown here are some examples of heterogeneous mixtures. Homogeneous mixtures, in contrast, are uniform in composition throughout the sample. In other words, you cannot identify the different parts. Homogeneous mixtures are also commonly referred to as solutions. Shown here are some examples of homogeneous mixtures. When one substance dissolves into another, a solution is formed. A solution is a homogeneous mixture consisting of a solute dissolved into a solvent. The solute is the substance that is being dissolved, while the solvent is the dissolving medium. Solutions can be formed with many different types and forms of solutes and solvents. In this example, the solute is the Kool-Aid and the solvent is the water. Here are some examples of other types of solutions. Can you think of any more?